orbital and the subshells. So first, we divide or orbit or shell into subshells. The orbit or shell is divided into subshells. They are divided into subshells. Then the subshells are divided into orbitals. So now we can say orbitals are the subdivisions within the subshells. First, the orbit or shell is divided into subshells. Then the subshells are divided into orbitals. That is why we say orbitals are the subdivisions within the subshell. And the subshells and orbitals are named as S, P, D, F, G, H, etc. These are the names given to the subshells and orbitals. S, P, D, F, S, P, D, F. These are the main subshells and orbitals. So, the shells are divided into subshells. The orbits are divided into subshells. Then subshells are divided into orbitals. And the orbitals as well as the subshells are named as S, P, D, F, G, H, etc. These are the names given to the subshells as well as the orbitals. Now, let us think of the number of subshells possible in a given shell. Say the number of subshells in a number of subshells in a given shell. What will be the number of subshells? The number of the subshells will be the same as the number of the shell itself. Number of the shell. The number of the subshells is equal to number of the subshells is equal to the number of the shell. If it is so, you take the first shell, that is the K shell. You take the first shell, the K shell. The number of the shell, that is equal to 1. And the number of the shell is known as the principal quantum number. Number of the shell is known as the principal quantum number. It is called the principal quantum number. Principal quantum number, that is the number of the shell. So, number of subshells is equal to number of the shell or the principal quantum number. I told you the principal quantum number is the same as the number of the shell. So you come to the first shell, the K shell. The number of the shell is equal to 1. So the principal quantum number of the shell, K shell, is equal to 1. So how many subshells are possible here? In the K shell, the number of the shell is equal to 1. Principal quantum number is equal to 1. So there is only one subshell possible. Only one subshell. In the K shell, there is only one subshell. That means the shell and the subshell both are the same. The shell and the subshell both are the same. And what will be the name of the subshell? The name of the subshell is, do you remember the names are S, P, D, F, etc. And here there is only one subshell and it is called the S subshell. S subshell. It is the S subshell of the first orbit. And so it is denoted as 1s, 1s subshell. Now you come to the second shell, that is the L shell, second shell. The number of the shell that is equal to 2. The principal quantum number of the L shell that is equal to 2. Therefore, the possible number of subshells that is equal to 2. Two subshells are possible. Two subshells. And these subshells are S and P. S and P. And these are the subshells of the second shell. And therefore, these are named as 2S and 2P. These are named as 2S and 2P. In the L shell, two subshells are possible because the number of the shell is equal to 2. The principal quantum number of the L shell that is equal to 2. And therefore, two subshells are possible. And the two subshells are S and P. And these are named as 2S and 2P. 2S and 2P subshells. Now you come to the next one. That is the M shell. That is the third shell. Here, the number of the shell is equal to 3. The principal quantum number is equal to 3. And therefore, 3 subshells are possible. Here, 3 subshells are possible. And the 3 subshells are S, P, and D. S, P, and D. And these are the subshells of the third shell. And therefore, they are named as 3S, 3P, and 3D. 3S, 3P, and 3D. So, the subshells possible in the M shell, that is the third shell, they are 3S, 3P, and 3D. 3 subshells are possible. Now you come to the next one, that is the N shell. Here, the number of the shell that is equal to 4. The principal quantum number is equal to 4. So 4 subshells are possible. 4 subshells are possible here. And these subshells are S, P, D, and F. And these are the subshells of the fourth shell. So to distinguish the subshells, we give the names as 4S, 4P, 4D, and 4F. 4F, these are the subshells. Say, in the fourth shell, or the fourth orbit, that is the N shell, 4 subshells are possible. And the 4 subshells are 4S, 4P, 4D, and 4F. Now you come to the next one. MNO. That is the fifth one. So here, the principal quantum number is equal to 5. The number of the shell is equal to 5. Therefore, 5 subshells are possible. 5 subshells are possible. And the 5 subshells are S, P, D, F, and G. And therefore, these are named as 5S, 5P, then 5D, 5F, and 5G. See? Similarly, you come to the next one. That is the MNOP. Here, that is equal to 6. And therefore, 6 subshells are possible. 6 subshells are possible. And these are 6S, 6P, 6D, 6F, 6G, 6H. But these subshells are not there in the given, the known elements. In the known elements now, these subshells are not there. These are only the predictions. Similarly, you come to this 5G, that subshell is not there because such an atom has not yet found out. It is your duty to find out a new element with a 5G or a 5H. It is given that. These are only the predictions. We have atoms containing only S, P, D, and F subshells. We have atoms containing S, P, D, and F. G and H, all these are predictions. All these are predictions. Say, till now, till this moment, we have the atoms containing S, P, D, and F subshells only. Although G, H, etc. subshells are possible, all these are predictions only. Practically, we have the atoms containing only subshell up to F. F means 5F, only up to 5F, 4F and 5F. Okay. So, let me repeat what I have taught you so far. Say, first of all, the shells or orbits are divided into the subshells. Then, the subshells are divided into the orbitals. The subshells and orbitals are named as S, P, D, F, etc. S, P, D, F, etc. Okay. Now, the number of the subshells possible is the same as the number of the shell, which is known as the principal quantum number. So, in the K shell, the principal quantum number is equal to 1 because it's the first shell. The number of the shell is equal to 1. So, only one subshell is possible and it is 1s. Now, come to the second shell, that is the L shell. Principal quantum number is equal to 2. Two subshells are possible and they are 2s and 2p. Now you come to the third one, the M shell. The principal quantum number is equal to 3. 3 subshells are possible. They are 3s, 3p, and 3d. Now the fourth one, the N shell. 4 subshells are possible, 4s, 4p, 4d, and 4f. Then one more you take, the O shell. The principal quantum is equal to 5. 5 subshells are possible and they are 5s, 5p, 5d, 5f, and 5g. All right. Now, let me ask you a question. Say, let me ask you a question. All of you, please come on the stage. Let me ask you. Say, you are given some subshells like this. Say 1s, 2s, 3s, 4s, etc. are given. Similarly, you are given some P subshells. Say 3P, 2P, 4P, etc. are given. Some D subshells are given. Say 3D, 4D, etc. F subshells, 4F, 5F, etc. Now, my question is this. If you are given some subshells like this, say 3F. Now, question is this. Is 3F possible or not? Nantana. 3F. Is it possible or not? Nandana.
No, sir.
Why? Because F begins from, come on. F begins from,
Fifth.
come on.
The fifth orbital.
For the fourth shell, for F.
Oh,
Say,
sorry.
yes can be, remember this, yes can be 1s, 2s, 4s, etc. Yes can start from 1s. So 1s is possible, 2s is possible, 3s is possible, etc., etc. are possible. All right. But what about P? 1P is not possible because P begins from the second shell only. S. See? S, P, D, F, G, etc. Remember? S, P, D, F, G, etc. So S begins from 1s. It can begin from 1s. While P, it begins from 2P, second shell. 2P. 1P is not possible. That may be the question asked. That is why I'm repeating. Meenakshi, Malavika, Alvin, Steffi, Anna, Michael. All of you, do you get me? Can you hear me?
Yes, sir.
Get me,
Yes,
Nia?
sir.
Okay. So 1P is not possible. Then D. Yes, P, D. So D begins from which D? Donna? Donna. D begin from? Not clear. It's not clear. I shall repeat. In the first shell, the principal quantum number is equal to 1. So only one subshell is possible. Navi, only one subshell is possible. And it is 1s. What are the names given to the subshells and orbitals? First you think of that, Emmanuel. Emmanuel, you think of that first. The names given to the subshells and orbitals. These are the basic things. If you make it thorough, then only I can proceed. So you make this thorough first. Only after that we can proceed. All right? Okay. So, you think of this. First shell. What are the names given to the subshells? S. Okay, you say S. Come on.
E,
P, D,
D,
F,
F,
G,
G.
etc. Yes. Yes begins from, that's the first one. Yes. So yes begins from 1s. 1s is possible. Okay. Then P, second one. It begins from 2P only. 1P is not possible. All right. Manuel. Then D, the third number, third name. So it begins from 3D. Manuel, do you get me? It begins from 3D, 3D only. 3D only. D begins from 3D only. 1D is not possible. Okay? 1D is not possible. 2D is not possible. 3D is possible. 4D is possible. 5D is possible. 6D is possible. All right? All right? Clear?
Yes, sir. Yes, sir.
Similarly, F.
Sir.
S, P, D, F. The fourth one. So, F begins from Aryan. F begins from?
4F.
4F. Yes. 4F only. 1F, not possible. 2F, not possible. 3F, not possible. 4F, possible. 5F, possible. So, you will be given a set of orbitals or a set of subshells. And you will be asked, which is not possible? which is not possible. A question. Say, for example, you write a question there. You write a question. You write? You write there. You write. 4s, 4s, comma, 4d, then 3p, comma, 3f, 3f. You are given 4 subshells, 4 orbitals also. Now, Ashwin, let me ask you. After this, which is not possible? Come on, unmute and say, which is not possible? You take this order. Come on.
Sir, 3F, 3D,
3f is
3D,
not possible.
4F.
Very simple. It is very simple. S, P, D, F, G. 1, 2, 3, 4, 5. Okay? All right? Say S, P, D, F, G, H. 1, 2, 3, 4, 5, 6. You correlate this. Correlate. S, 1 as onwards. P, second one. So 2P onwards. D, third one. 3D onwards. F, fourth one. 4F onwards. G, fifth one. So 5G onwards. All right? Such questions will be asked. You will be given a set of say subshells, and you will be asked which is not possible. All right? Okay. Now let me ask you another question. Say you are given the nth shell, shell n, K, L, M, N, K, L, M, N. N shell is given to you. N shell. How many subshells are possible in the N shell? Emmanuel, come on.
4.
4. Very simple, 4. And which are they? Come on.
4s, 4p,
Yes,
4p.
4s, 4p, 4d, and 4f. Yes, it is correct. Now you got the idea. It is clear.
Yes, sir.
So this is the way how the shells are divided into subshells, and subshells are divided into the orbitals. Okay, so make it clear. Only after that we can go further. Now let us go to the shell again. What will be the maximum number of electrons? Maximum number of electrons possible that you have studied in a shell. In a shell, what will be the number of electrons possible? Maximum number of electrons possible. You have studied in the 10th standard. The maximum number of electrons in a shell, that is equal to 2n square. 2n square, where n is the number of the shell, where n is the number of the shell. If it is so, let us try to calculate the maximum number of electrons possible in the K shell. K shell, n is equal to K shell, n is equal to 1. So what will be the maximum number of electrons possible in the K shell? Emmanuel, you calculate. There is the formula 2n square.
2, sir.
2 into n is equal to
1.
1. 2 into 1 square is equal to 2 into 1 is equal to 2. Okay, that is correct. Maximum number of electrons possible in the K shell is equal to 2 only. L shell, maximum number is equal to 2 into 2 square. That is equal to 2 into 4 is equal to 8. Let us take one more. M. That is the third shell. So 2 into 3 square is equal to 2 into 9 is equal to 2 into 9 is equal to 18, etc. If it is so, what will be the maximum number of electrons in the P shell? P shell, you calculate, Punya. Maximum number of electrons possible in the P shell. K, L, M, N,
70.
O, P. Yes, come on.
36 into 2.
You calculate what is the number of the shell?
6.
6. Okay. So 2 into 6 square. That is equal to 2 into
36.
30. So K, L, M, N, O, P. So that is equal to, come on,
36.
is equal to, that is equal to
72.
72. That is 72. You have to make a correction in the notes sent to you. M, N, O is not given. Instead of that, P is written. You make the correction in that. I have written 50, 50. That is not a P, that is O. Make the correction in the notes. M, N, O, 5, O. That is equal to 2 into 5 square is equal to 50. Instead of P, you write O. Make the correction. O. The notes is there with you, no? Okay. So the maximum number of electrons in an orbit is equal to 2n square. If it is so, K shell 2, M shell KL, L shell 8, M shell 18, etc. Okay. Now, what is the maximum number of electrons possible in an orbital? Maximum number of electrons possible in an orbital, that is equal to 2. That is equal to 2. Orbit 2n square. Orbit 2n square. While orbital maximum, that is equal to 2. In an orbital, there can be maximum of 2 electrons only. If it is so, we can calculate the number of orbitals in a given shell. In a given shell, what will be the number of orbitals? Say, number of electrons in an orbit. Number of electrons in an orbit is equal to 2n square. 2n square. 2n square. Maximum number of electrons in an orbital, that is equal to 2. Therefore, number of orbitals in an orbit, that is equal to number of orbitals possible in an orbit, that is equal to number of electrons 2n square. 2n square. In an orbital, 2 electrons. Total number of electrons possible in an orbit, 2n square. Maximum number of electrons in an orbital, that is equal to 2. So you divide the total number of electrons in a shell by the number of electrons, maximum number of electrons in an orbital 2. So 2n square is divided by 2. That will give you n square. N square, that is the number of the orbitals possible, where n is the number of the orbit or the principal quantum number. So I shall repeat this. Maximum number of electrons in an orbit is equal to 2n square. Maximum number of electrons in an orbital is equal to 2. Therefore, the number of orbitals in an orbit or shell is equal to n square. That is equal to n square. Okay. So you will get the number of orbitals in an orbit. Now you come to the subshells. The subshell, SPD, F, etc. The subshells. That will be the maximum number of electrons. Maximum number of electrons in a subshell. In a subshell. In a subshell. What will be the maximum number of electrons in a subshell? You come to the S subshell. The maximum number is equal to 2. In a S subshell, it may be the 1s, it may be the 2s, 3s, 4s, whichever S it is. Whichever S it is, the maximum number of electrons possible, that is equal to 2 only. Then you come to P, maximum number of electrons possible, that is equal to 6. Then D, maximum number of electrons possible, that is equal to 10. Then maximum number of electrons in the F level, that is equal to 14. Then G, it is not there. It is not there. And it will be 18. 18. See? Plus 4, plus 4, plus 4, plus 4. Arithmetic progression. AP, AP, AP. N plus D. See? A plus D. So similarly here, plus 4, plus 4, plus 4, plus 4. Okay. So that is the maximum number of electrons possible in a subshell. S, maximum 2. P, maximum 6. D, maximum 10. F, maximum 14. And G, maximum 18. If it is so, we can find out the number of orbitals possible in a subshell. Number of orbitals. Number of orbitals in a subshell. Number of orbitals in a subshell. What will be the possible number of orbitals in a subshell? How can we find it out? In the S subshell, S subshell, maximum number of electrons possible, that is equal to 2. In an orbital, maximum is equal to 2 only. So 2 divided by 2, that is equal to 1. Only one orbital is possible. In the S subshell, only one orbital is possible. And it is known as the S orbital. S orbital. 1s orbital, 2s orbital, 3s orbital, etc. You come to P, maximum number of electrons in the P level is equal to 6. In an orbital, maximum 2. So 6 by 2, that is equal to 3. So in the S level, only one orbital is possible. In the P level, 3 orbitals are possible. And these are known as Px, Py, and Pz. Px, Py, Pz. It is getting time. So D, maximum 10 by 2 is equal to 5. 5 orbitals are possible. The details we can see the next day. Similarly, you come to the F level, maximum 14 by 2 is equal to 7 orbitals are possible. So now we have calculated the number of subshells and the number of orbitals in a given subshell. S subshell, only one orbital. In the P subshell, 3 orbitals. In the D subshell, 5 orbitals. And F subshell, P orbitals. Remember this? Orbit or shell divided into subshells, SPDF. Then subshells divided into orbitals, S orbital, P orbital, D orbital, etc. So in the subshell, we have calculated the number of orbitals. S, 1, then P, 3, and in the D, 5 orbitals. F, there will be 7 orbitals. then 9 orbital G, 9 orbitals, etc. So we have calculated the number of the subshells and the number of the orbitals in a subshell. It may be 1s, 2s, 3s, whatever it is, maximum 2 electrons and 1 orbital. P. P may be 2p, 3p, 4p, 5p, whichever p it is, maximum 6 electrons and 3 orbitals. D. 3d, 4d, 5d, 6d, etc. Whatever d it is, maximum 10 electrons and 5 orbitals. F. 4f, 5f, whatever f it is, maximum 14 electrons and 7 orbitals. You remember all these things. With this, we can continue the next day. It is time. Let me stop now. Thank you.